Hello and welcome back. So in this lecture, we are going to discuss about the RelU, another activation function which is used in the neural networks. So RelU is known as the rectifier for the neural network. And if you have to understand with the help of a layman example, then you can consider a light switch. You know that whenever you flip a light switch on, it is either on, it will be either switching the light on, or when you are flipping it off, then the light is off. So there are only two states. One is on and the other is off, right? So that's how essentially the RelU works in the neural network, right? So let us see how it works. So it works on the two inputs, positive inputs and the negative inputs. Okay. So if the input to a neuron is positive, RelU let it pass through unchanged. Suppose you are working on some problem, you are training your model, and you have to train your model. Then on certain conditions you will be sure that yes, this is what I wanted and there is no need of any processing. Then you just let it go, you accept that input, you just don't do anything, you just accept that input. So that is something is known as the positive input. So RelU does the same thing. If the input to the RelU activation function is positive, then in that case it will let it pass through. It's like the light switch being turned on. And what is negative input? If the input is negative, then RelU shuts it down, setting the output to zero. It's like the light switch staying off, right? So you can understand it's very simple to understand like how it is working. So it is working on only two values, 1 and 0. So there is no such thing like you have to think too much about the threshold. There is a certain threshold limit above which something is accepted or not accepted. That's it, right? So there is not much. Okay. So why this is useful? Here there is some mistake, and let me tell you that this uh, these notes that you are able to see, these are not available anywhere. These are on my personal notes, and I will try that I should very soon be able to just distribute over some website, my own website, on my own web page. I will try to do that as soon as possible, and I will let you know once I do that. So let's move ahead and why it is useful. It is computationally efficient because it involves a simple threshold operation. What is that threshold? That's a binary threshold. Either it will accept or not accept. Right? Some criteria, some kind of criteria it has set. Like if you have the access card, then you will enter into the office premises. Otherwise, you need to go back. You will not be allowed to enter into the office premises. So a very simple threshold level makes it efficient. And the second thing is sparsity. By setting some activation to zero, RelU introduces sparsity in the network, which can improve learning and generalization. Okay, you can make it more generalized if you are introducing the sparsity in the neural network, because some activations you are making it zero, right? So you are not considering them, right? You are just letting it through. So it makes it very general on that line, right? And there is another usefulness of it, and that is like how it is beneficial over the sigmoid. That in case of sigmoid, you learned that there are vanishing gradients you already understood. Like there is a rate of change. I mean, there is a curve always. When you plot the data on the graph, it looks like some kind of curve. So on the curve you need to find out like how the data is changing, what is the rate of change of the data. So that rate of the change of data is known as the gradient, that you understood with the help of the calculus concept, which is known as the differentiation, right? So how some values or something is changing on a curve, that thing we can find out with the help of the calculus, and that's the concept of differentiation. Okay, so differentiation is for that only. Okay, so vanishing gradient problem you can remove here, which is a common issue in deep neural networks where gradient becomes very small during backpropagation. Backpropagation means learning, a feedback, right? Once you train your model, you start training your model. Then if you find that yes, your model is not that efficient, right? Then in that case, you understand that yes, I need to again train it with some other gradient. I mean, I need to find out the rate of change again so that I can put some correct values with respect to the rate of change. So you need to find out the gradient again. So while finding out the gradient in case of a sigmoid function, the gradient vanishes. I mean, you are not able to find out any more gradients, right? So that's why in the deep learning problem, deep learning, deep learning models for the neural network, you face that problem when you are using the sigmoid function. But in case of ReLU, you don't face that problem, right? So during the back propagation, it doesn't hinders the learning. During the back propagation, it is able to find out the gradients. The gradient doesn't vanishes that rapidly. Okay, so in essence, ReLU acts as a rectifier, allowing only positive information to pass through and blocking negative information. This simply maintains that how uh, the information will flow through it, and unnecessary things I don't need to work on. So that's how it works. So simple mechanism is there, which is highly effective in improving the performance of deep learning models. So with this, I would like to conclude this video. In the next video, we will see the visual representation of the ReLU function and a real life example where you can use the ReLU activation function if you are training a model. So what could be that real life example? With the help of that, you will be able to understand that in what situation you will be using the ReLU activation method. So till then, have a nice day and bye.